Okay, so we discussed last time that we need several indicators to help us into making the decision for projects. So if it's economically profitable or not. And we talked about the internal rate of return. And we said that larger internal rate of return are good because they will allow us to have a large interval of discount rates for which we can have a profit. So it's good to increase the IRR and reduce the discount rate. So don't confuse between the two, because a larger discount rate means that the value of money at present is lower, which is not good, which will make the payback period longer. But the internal rate of return, it's good to have it high because it will give all possible range of discount rates for which the NPV at the end of lifetime will be positive. And we'll see in this session that sometimes in order to make a decision, we need to compare several factors. We can calculate the internal rate of return, let's say, for different projects, and also we should compare the NPV. In majority of cases, the two will give us the same recommendation. But sometimes we'll have, for example, a higher internal rate of return for a certain project, but a lower NPV or lower CER. We'll discuss what do we mean by CER now. And therefore, we have a contradiction, so we should make a decision. We'll take together an example to see what is the difference between the two aspects. Okay. So let's say I want to, I have two projects to compare. Okay. One possibility to make the decision is to calculate first the internal rate of return. It will help me into making my decision. Because if a firm defines a required return on its investment, a preset threshold investment rate is known as the hurdle rate. The hurdle rate is the discount rate or the WACC that we defined last time. And as we said, it represents the cost of capital. What do we mean by this? So in case I want to invest my money, I want to make sure that it will give me profits more than if I use it in somewhere else. And if I put on a bank, for example, my money, I am expecting to have a profit of this percentage per year. Or if I go towards doing another project, I am expecting to gain, let's say, 10% per year. So I should make sure that my hurdle rate or cost of capital will, if you want, represent, okay, the percentage that I am expecting to gain if I go and use my money in other way. Okay, and we said that we can calculate it through the following formula. So the WACC is the cost of capital. Okay, so if it can be decomposed into a debit part and an equity part. We said that the debit, if I take a loan from the bank, okay, and equity is my own money. So for example, when I take a debit, I should consider the percentage, the interest rate I should pay to the bank. So I should expect to have a larger gain in order to be able to give back this 5%. And for the equity, we said it's the percentage that I am considering that I can gain in other projects. So if I have a certain capital and I am investing it in the market and I'm gaining 8% per year, then I can say I will take this discount rate when I do the analysis of my WACC. And in overall, the WACC will be a combination of these two. So here it's 70% times 5% plus 30% times 8%. And if I want to compare two projects, I should first calculate the internal rate of return for the two, because it will help me taking my decision. Okay. Now we'll discuss two things. We'll discuss the first case if I have.
Hi, Professor.
Hello, Kari.
Sorry, تأخرت.
It's fine. So if I have two options, okay, and I want to select one good idea is to compare the IRR. Now we'll see together that the IRR is not the only thing to compare, okay? So we will work on two aspects. We will compare the internal rate of return, but also another aspect that is important is the net present value per unit capital, per investment. Okay, so we already have seen that this is called the capital enrichment rate, CAR. The CAR is equal to the NPV over I. Okay, so in general, what we try to do is to increase the CAR and at the same time to increase the internal rate of return. Okay, so we can say in general that if we have two projects, the ideal scenario, and we want to compare project 1 and 2, the ideal scenario will be to have IRR of project 1 larger than the internal rate of return of project 2. And also, it's desired to have the CAR, so the capital enrichment rate of project 1, larger than the ratio for project 2. Okay, but in case we have contradictory results, which might happen, we'll see why. Okay, then the CER is more important, because it will represent our percentage of gain. Okay, so in case we have IRR1 smaller than IR2, but CER1 larger than CER2, we say that the CER is a more important factor, and we opt for project 1. And of course, it would be better if the two conditions are satisfied. So of course, we'll go to project 1. But if we have CER1 smaller than CER2 and ERR1 larger than the ERR2, we prefer project 2 because the CER is more important than the internal rate of return. Okay. So here we'll develop, let's say, some tools to help us into the decision. So in case we have just one project, and we want to see if we continue with this project or not, we should compare the internal rate of return with the WACC or the hurdle rate or discount rate also. And it has several names: hurdle rate, WACC, or discount rate. The discount rate, of course, should be smaller than the internal rate of return, because for any A between 0 and the internal rate of return, the net positive value, okay, the net present value at the end of lifetime will be larger than 0. But also not any A will be acceptable, okay, because it's not enough to have just NPV larger than 0. We need to gain money. So this is why we say we'll define the capital enrichment rate, which is the ratio of the net present value at the end of lifetime. So this is at year end, over the investment, and it is advised, okay, to have it larger than 0.3. When we talk about 0.3 in general, it is for renewable energy investments, because larger the period you are working on, the larger the percentage you can expect. And if you have a project for 1 year, it's fine if you gain 10%, it's very good. For 1, 2, 3 years, if your percentage of gain is let's say 10%, it's fine. But if you have a project for 20 and 30 years, you should have larger CER. So in general, the threshold for CER should increase with the lifetime of the project. Larger lifetime will require a larger CER to be acceptable. Okay. So until now, the IRR can help us into knowing the range of discount rates we can work with. We can also define, if you want, the rate for which we have a profit that is acceptable. So if I tell you the CER for this project should be larger than 0.3 to consider that it is profitable, then you should do by iteration what is the discount rate A, which will give me a CER of 0.3. I will take an example on this. Okay, and in case you have two projects to compare, you should consider first to compare their internal rate of return. if you base your decision only on the internal rate of return, of course, the one with larger rate of return would be better. But it's not enough to calculate one indicator and base your decision on. We say also the CER is another factor. And we consider the CR more important because it represents the actual percentage of gain that you will get from this project. Any question on this? Okay. Now, so as we said, the internal rate of return is an important index. It's easy to communicate. However, what can we think if we have to compare two projects, let's say, with same lifetime, same risk profile, same capital requirement, same financing structure, and same cash flow characteristics? If we have all of these that are the same and we want to compare the two projects, we should not only consider to the comparison of the internal rate of return. So we can consider NPV and IRR. But the problem is when we have contradictory results. Why we can have contradictory results if we calculate these two? Because sometimes if you want the cash flow characteristics will not be, it's impossible to have exactly the same profile. You can have similar profiles between two projects, but if they are exactly similar, they will have same NPV and same IRR. So in overall, they are similar, but we have some differences, okay? And because of these differences, we can have different, if you want, recommendations if we base on NPV and IRR. Why? Because let's say, consider that you have a certain project with high investment. Okay, if the investment in project A, for example, is larger than project B, it's true that for larger investment you expect you expect larger incomes. Okay, but with time, you know that with time if you want, the value of your income will become lower, because for each year you will do income minus cost over 1 plus A. And with years, okay, the advantage of having high income will be reduced because you are dividing by 1 plus A to the power I. So a lot of factors will affect, if you want, your net present value. We'll do an example. That's, for example, if you take the comparison of two projects for a certain, if the lifetime is 10 years, you can select A as option, but if the lifetime is 20 years, you might select B, because with time, the amount of gain will be reduced. Okay, so the cash flow with time will affect a lot our decision. So sometimes we can have an IRR for A larger than for B, but for the NPV, it's opposite. NPVA is smaller than NPVB. That's why, in general, it's good if we can have both better, but if not, we base in general on the NPV. Okay. And for the differences between projects, we might have some differences. Not always we have the same, let's say, lifetime, or not always we have same financing structure. So if any of these aspects will differ, then we might have contradictory results. And that's why we need to come up with, let's say, a technique to select the best option, which is to check both factors and base our decision on this. So if two projects have different lifetimes, for example, the IRR of the project with a short lifetime could be higher than that of the project with a longer lifetime, but the net present value of the former could be lower than that of the later. So that's why, because whenever we have longer period, we have larger risks, okay, and we might have a larger value for if you want, we might have more risks, so lower discount rate. Okay, and therefore for projects with short lifetime, we can have IRRs that are larger. But on the other hand, in general, when you have a larger lifetime, you can expect also to have a higher investment and higher return. So the NPV results might be different. That's why if we have a lot of differences, the better is to base ourselves on the percentage of gain, which is the CER, NPV over investment. So this means that the short-time return on the firm investment would be higher if the company invests in the shorter lifetime project, but the absolute value that is added to the company would be higher if the firm invests in the project that has a longer lifetime. So this in this case we have we have contradiction between results. So we can say the first project will have, let's say, a higher risk but also a higher NPV. So then it's up to us to decide if in general we consider that the CAR is more important. But in case we are in a country where the risk is really high, we might have to opt for the other decision. So all depends, if you want, on our situation and on the type of projects we are investing in. Let us take a numerical example to apply all of these rules and see how we can make our decision. Okay, so we have now two projects and we want to perform a certain comparison to decide which project is better. Okay, so I will put here the all information needed to do the calculation. So first, let me write the given. Okay. Sorry, just 1 minute. Okay, so we have Jihad wants to start a new job. Do you see, or let me increase the font?
Yes, yes.
Okay.
I'm sure.
Okay. So Jihad wants to start a new job. He wants to buy a machine. Please take note. Okay? You don't have, this is a problem that we'll do together, so you can take note. So he wants to buy a machine. And he has two options. In option A, the machine is fully automated. The cost is $20,000. It doesn't require any operational cost.
As free maintenance cost.
Yes. So no operational cost. And the maintenance is 1% of the investment per year. The maintenance is 1% of the investment per year. Now, a second option, so B, the machine needs an employer. Okay, so we need an employer to operate it. هلا it's يعني you don't want the employers the whole time يعني it just need to if you want to put it in operation. This is why the salary is limited. So with a salary of $2,000 per year, and the cost of the machine is $5,000. And the maintenance is 2% of the initial investment. The maintenance is 2% of the initial investment.
والماشين ما عندها لايف تايم.
مبلا أكيد يلا بعد في information. Okay. Now, machine A can produce 1,000 items per year. While B can produce 800 items per year. The discount rate is 5%. The salvage value of A is $1,500. And for B, it is $300. The price per item is $4. And the lifetime is 8 years. And the lifetime is 8 years. Okay. So now we want to decide which option we should go through. Okay. So perform an analysis to decide on the best option. Okay. So first, as we mentioned now, we should compare both the internal rate of return and the CER. Okay. Plus also here we can consider first, it can be a question on a design. Okay, whenever you want to do the let's say, what is your problem here? You want to select a certain machine. Okay, so you have to do a decision. You have to your problem is, I want to select a machine that is appropriate for my job. So you can first do some small research or what is the appropriate machine to use. You can go to the market, compare several machines, and at the end you will come up with some you will reduce your alternatives if you want after considering a certain decision matrix. So in your decision matrix you will say, let's say, which machine will what is the noise from each machine, what is the cost, what is the operational and maintenance cost I have. So after doing all of these, you can end up with, let's say, these two alternatives. So if you want, this is the final stage of the design process. We already did the whole study, but we at the end we have these best two options. We'll do another problem together and how we can formulate the design problem and how we can draw the decision matrix, and then how we can come up with the final, if you want, important alternatives that will compare economically. Okay, so here they already gave us the two options, and we have several information given that will allow us to compare the internal rate of return and the CER. Okay, first, to be able to calculate the internal rate of return or the CER, what should we do? Which function is important to set first?
We can use present verse or annual verse.
Yes,
We equate it to
exactly.
zero.
So first, we should express what is the net present value. Okay, function of, if you want, the internal rate of return. We know that the internal rate of return is the rate for which the NPV at year end will be equal to 0. So we need to express first the net present value, a function of the rate. Okay, so all we have to do is to apply the formula. What do we mean by net present value? We know that it will account for all costs and incomes over the whole lifetime. Okay, so NPV at year end, which is the final year, which is 8 years, because the lifetime of these two projects is 8. Okay, so we have the NPV is equal to 8, and we have that first we have the cost for year 0, so it's minus I0 plus summation from 1 to 8 of the income, so RI minus CI over a 1 plus A to the power I. And sometimes if you have, let's say, a short lifetime, and for example 8 years is relatively short. Okay, so since 8 years is relatively short, maybe you will not have enough time to pay back your investment, and you are paying in A $20,000, while in B, as a first investment, you are only paying 5,000. Okay, so maybe you need more time to compensate 20,000. So this is a factor. So lifetime will be a factor. Okay, plus also the difference between income in machine A and machine B will affect your result. Yani, of course, the machine with a larger price will have a larger RI minus CI. So at the end, to be able to answer, we cannot do it if we don't do the whole calculation. Yani we need to perform the calculation for both cases in order to decide. Okay, so as a first step, if we want to apply for machine A, for machine A, we have the investment is minus 20,000. Now, concerning the income here, for A, what will be the income per year? So which information should we use for A? What is the income per year? They told us that machine A can produce 1,000 items per year. So the productivity is related to the income plus we know that the price per item is $4. So per year, we can say that the outcome is 4 times 1,000. Okay, so we have 4,000.
Professor,
Yes,
isn't this the revenue? Does
yes,
this take into account the cost?
yes, this is the income. This is the income. It's the revenue.
Oh,
Yes.
okay.
The cost,
It doesn't
now
take
we'll
into
do
account the cost.
now we'll do minus. Okay, so we do summation from 1 to 8. What is good here, which will make things easier, is that we don't have variation with years. In general, we can have, for example, for year 1, the cost is equal to this amount. For year 2, another amount. Then we'll have to decompose. If you want, we'll have to decompose the expression of summation. Also, we'll do this in another example. But here it's relatively simple because for each year you have the same income and same cost. So for machine A, it's fully automated. Because it's fully automated, you don't have operational costs. You just have the maintenance cost, which is 2% of the initial investment. So minus 0.02.
يعني 100.
Yes, times 20,000, يعني 100. Okay. And now over 1 plus a to the power I. Here, because it's this factor here is constant, you can take it outside of.
بس Professor.
Yes.
هي ال 2% لل $5,000.
لا عم بحكي بماشين
للماشين
A. It's machine A now.
يعني 1%.
Sorry, 1%. Yes. Sorry, 1%. Exactly. The maintenance is 1% for A. So it's 1% of 20,000, which is 200. Yes, which is $200. Yes. Okay. So now what we can do, we can take this factor outside and we get the expression for the NPV. Okay, so let me erase this. So we can say now that the NPV for machine A is equal to minus 20,000 plus 3,800 times the summation. Okay. Now, in your calculator, you can solve for the value of the internal rate of return. And also we can do it by iteration. And we can do plus 3,800 times the summation. If you want to do it by iterative procedure, so if I ask you to determine the internal rate of return by iterative procedure, all you have to do is to draw a table. Okay, so this is 1 over 1 plus a to the power I. You do a table and you try several values